coming up, Nova gets covered with electrodes to test her anxiety level.
Educational neuroscience explores how we learn. For instance, when we're figuring out a math problem, what's happening inside our brains? How do our bodies react when we don't understand something? And how does what we are feeling emotionally affect our process of learning? In the Faculty of Education at Simon Fraser University, Professor Stephen Campbell has designed one of the world's first facilities dedicated to educational neuroscience, and they call it the ENGRAMMETRON.
Have some general knowledge about, they have a general sense factories out there.
Our interests in brain behavior and body behavior is how that relates to the lived experience of learning. And we want to improve the quality of learning experiences. We want to be able to help minimize anxieties and improve comprehension. One is math anxiety. Their bodies can just really freeze up, their minds can shut down. What are the different nuances that are associated with anxieties? How can we help people to overcome those anxieties? These are questions that the lab has been in part set up to explore.
Okay, what we're having here is a pre-screening questionnaire. Have you ever had any seizures before?
No.
Anyone in your family?
No.
Emotion's hugely important in learning. It can affect attention, it can affect retention, it affects the process of how memory is stored, and it also affects our general being.
Oh, it's asking me if I have any unrelenting fears about the future. Don't we all?
Anxiety is quite well mapped. We know what part of the brain is activated when someone's anxious. We know the kind of physiological experiences they're having. Their heart might race, they'll feel cold and clammy. They might fidget, their eyes might dart all over the room.
I was curious about my own experience of learning, so I decided to volunteer for one of their experiments.
How do you feel?
I feel like a guinea pig.
That would make it in the runways of Milan.
Thank you. Whole new look.
You ready to go into the observation room?
Absolutely.
Excellent. All right, just watch your step.
The experiment takes place in a tiny, soundproof observation room called a Faraday cage.
Now let's get you nice and comfortable. One of the real distinctive aspects of the Educational Neuroscience Lab is that we're combining both the overt traditional behavioral methods and integrating that with the psychophysiological methods of cognitive neuroscience, particularly electroencephalography, electrocardiography, the EKG, galvanic skin response. We're looking at skin temperature, respiration rates, pupil dilation. Okay, Nova, you can begin now.
My task for this experiment was to choose which of these geometric shapes was not like the others. I was coasting along until I came to this one. I was stumped.
Nova, I'm going to ask you now if you could talk aloud about your experience the first time through.
With this one, it was obvious to me that all of the shapes except for one were vertical. And with this series, first I was looking at all the shapes and I realized that one was solid and the others were empty. This one was a hard one. I don't know. Do you have any other hints?
Imagine laying both lines on top of each other.
I don't know. I can imagine all of them kind of rotating to line up. This one.
Why?
Because if they lay on top of each other, they wouldn't line up. Is that the right one?
There's no right and wrong.
I knew you were going to say that.
We have put the energy coming from your left and right hemispheres.
Campbell and his team are only at the initial stages of their research, and over the next several months, will be working to analyze all of the data they've gathered so far.
One of the things about mathematical thinking is that we're often stuck before we're enlightened. And so when we combine the EEG with the eye tracking, we see the progression that you're making in going through and comparing one slide, or one diagram on the slide with another. That gives us some real insight that we've never had before. One of the most amazing phenomena in math education is the so-called aha phenomena, those moments of insight where, you know, we can be struggling, then all of a sudden we get it. And the light goes on somehow. What's involved in that? How can we help people have these experiences more readily? If there was some point where all of a sudden you would have seen what the answer is, that would have been an aha moment.
I never quite got there, though, did I?
That's right, but here is a participant who did. Here we see that the gaze is on the prompt diagonals. And what our participant is going to do is he's going to systematically come through and look at each of these in turn. And this is the moment where he says, ah.
Ah, okay. Yes, I see this quite differently now. Here, when I see the word diagonals, it's definitely prompting me for what to look for, and I can clearly see that this one is the only one where the dot is not on the diagonal.
In order to be able to understand cognitive events that can occur over the course of a few hundred milliseconds, we really need to capture this in very minute detail. Scientifically, with electroencephalography, we're able to actually measure the movement of free electrons on the scalp, and it's very much like a weather system. And so sometimes we have brainstorms and we generate a lot of energy. The weather is very dynamic, and other times it's more peaceful, like when you're at rest, for instance.
Other industries, mining and so on, there's a direct...
Anything that we can do to help people become more conscious, whether it's about mathematics or about their own state of being, I think this falls within the purview of education and educational research. How have we come to know the things that we know? What is it that we know? How might we think differently? How might we improve ourselves? These are key questions that are motivating me to help expand the dimensionality of educational research.